So welcome. This is a test for AAHL Mathematics Derivatives for IBDP and test number 2. So we are going to, what is this? Solve the questions based on the topic derivatives, and it's a comprehensive test having all the topics concerned with the derivatives. So let us start with the first question. Show from the first principles the derivative of this one equals to this. So we have to show that the first principle. So what is first principle says f prime x equals to limit h approaches 0 f of x plus h minus f of x divided by h. So what does it mean? Instead of x, you have to plug in x plus h in the function. So what does that becomes? 1 upon 2 times x plus h plus 5 minus 1 upon 2x plus 5. So you have substituted this is f of x plus h and this is f of x whole divided by h. This is going to be the answer. Instead of x, wherever x is there, I am going to plug in x plus h. This is f of x plus h and this is f of x. Now I need to simplify and I have to get it out this as the answer. So what is that? Limit h approaches 0. What can I do? I can take 1 upon h as a denominator common, so that what does that becomes now? So common denominator for both. The common denominator for both is 2 of x plus h plus 5 times 2 of 2x plus 5. This is a common denominator. Multiply both the denominators, that becomes a common denominator, then do the cross multiplication. So that becomes 2x plus 5, then minus this, also do the cross multiplication. So when I do the cross multiplication, let me draw an arrow over there, cross multiplication, so it becomes minus of 2x plus 2h plus 5. Now you have to simplify this one further. So limit h approaches 0, 1 upon h. So this becomes 2x plus 5 minus 2x minus 2h minus 5 divided by, no need to expand this because anyway we are going to plug in h as 0. So 2x plus 5. Now you see everything is about simplification. So 2x gets cancels, 5 gets cancels, and this h and h gets cancels. Follow the color coding, and the h over here becomes 0. H over here becomes 0. So because limit h approaches 0, so what am I left over with? Nothing but what? I am left over with negative 2, and over here it is 2x plus 5, and over here it is 2x plus 5. 2x plus 5 times 2x plus 5 is 2x plus 5 whole square. That's going to be the answer. See the simplification? H is 0 and one of the h gets cancels. Follow the color coding, and 2x plus 5 will become 2x plus 5 whole square. Now question number 2. What's question number 2? Find the derivatives of the following. What is he asking us to find? The derivatives of the following: e power 2x sin x and cos e power cos pi upon 7. So f prime x. So first part, f prime x, e power anything will be the same thing, e power 2x sin x times derivative of the power. Power is again a product rule. So product rule, what is that? This is u and this is v. So uv prime, vu prime. So u is 2x as it is, sin x derivative is cosine x. Next time sin x as it is, 2x derivative is 2. This is going to be the value. Now e power cos pi by 7, its derivative is going to be 0 because it is a constant. Constant derivative is 0. That's going to be the answer for part A. Part B, sin ln x. Sin ln x derivative is cos ln x, and ln x derivative is 1 upon x. Next one, ln sin x. Ln sin x derivative is 1 upon sin x. Sin x derivative is cos x. So that's going to be the answer. Next, part C, h prime x. Log 2 to the base x. Log 2 to the base x. So first of all, what we can do it out is, I can write it as log 2 to the base x as I will be simplifying. Before finding the derivative, I will be trying to simplify that one. So how do I write that? Ln 2 divided by ln x. Ln 2 divided by ln x. Then I introduced a base e, ln 2 divided by ln x. So plus similarly, log x to the base 2 can be written as nothing but what? Ln x upon ln 2. So convert into ln 2, then it will be easier. So h prime x will be 1 upon ln x. So remember, this is so many times we'll be doing it out. 1 upon x derivative is minus 1 upon x square. So remember, 1 upon x derivative is minus 1 upon x square. So ln 2 is a constant. 1 upon ln x derivative is minus 1 upon ln x whole square. So once again, 1 upon x derivative is minus 1 upon x square. So 1 upon ln x derivative is minus 1 upon ln x whole square times, again, chain rule. Ln x derivative is 1 upon x. This time, 1 upon ln 2 is a constant. Ln x derivative is 1 upon x. So see carefully how it has been done. This is the derivative of ln x, 1 upon ln x. Whereas this is the derivative of ln x. So see carefully how it has been done. Show that the derivative of the function y equal to arc tan x is 1 upon this one. So what am I going to do for that one? Y equals to arc tan x means y equals to tan inverse of x, means tan x equals to, what is that? Tan y. Bring the tan to this side, tan y equals to x. Differentiating on both sides. So tan y derivative is secant square y derivative is dy by dx, and x derivative is 1. So dy by dx equals to 1 upon secant square y. Now we know the identity, secant square y minus tan square y equals to 1. So what is secant square y? Secant square y is 1 plus tan square y. So what is that? I can write it as 1 upon 1 plus tan square y. But what is tan y? X square. So 1 upon 1 plus x square. That's going to be the answer. Question number 3. Now coming to question number 4. Consider the function g of x and g prime x exist. G of x is equal to g of e power 2x. Find f double prime x. So what is that? F of x equals to g of e power 2x. Now f prime x. F prime x will be g prime of e power 2x times e power 2x derivative is e power 2x times 2x derivative is 2. Chain rule. This e power 2x derivative is over here. E power 2x times 2. This is f prime x. Now f prime x can be written as in the standard form, right in an order, 2 times e power 2x times g prime of e power 2x. Now this is u and this is v. So again product rule. So f double prime x will become 2 will remain as it is, e power 2x. G prime x derivative is nothing but what? G double prime e power 2x. Again e power 2x derivative is e power 2x and 2x derivative is 2. Then plus next time g prime of e power 2x will remain as it is. E power 2x derivative is e power 2x times 2. What is that? This is u, this is v prime, and this is v and this is u prime. uv prime plus vu prime. Now you want to expand it out and simplify that. What does it becomes? Now it becomes 4 e power 2x, 4 e power 4x. Why? Because this is e power 2x and e power 2x will become 4 e power 4x g double prime e power 2x plus 4 e power 2x g prime of e power 2x. That's going to be the answer. So coming to the question number 4b. Given that g prime of 1 equals to g double prime of 1 minus 1 equals to 2, find f double prime 0. So we are supposed to find f double prime 0. So substitute f double prime 0 in this one. So e4 e power 0 times g double prime e power 2 times 0 plus 4 e power 2 times 0 g prime of e power 2 times 0. To make you to understand easily, wherever 0 is there, I'll write that one in red color so that it is easy to understand what am I substituting over there. 0, 0. Now, we know that e power 0 is 1, g double prime of 1 plus 4 e power 1, g prime of 1. Now, which is 4 g prime of g double prime of 1. What is g double prime of 1? G double prime of 1 is 3. See carefully, g double prime of 1 is 3, not 2, because this minus 1 goes to the other side. G double prime of 1 is 3. Then plus 4 e power 0. This is not 1, e power 0. So e power 0 is 1 and g prime of 1 is nothing but what? 2. So which is 12 plus 8, which is going to be the answer 20. So be careful with the calculations. Question number 5. Then what is he asking in the question number 5? The line y equals to 4x plus m is a tangent at x equals to 1. Find the values of L, m and n. So they are tangent, the slopes will be equal. So what is the gradient? Gradient is equals to nothing but how much? 4 is going to be the gradient. Should be equals to gradient of this curve also. What is the gradient of that curve? Negative 6x square plus 2nx. Then, so at x equals to 1. So plug in 1, 4 equals to negative 6 plus 2n. That is one equation. I got it out. Or else 2n equals to 10, n equals to 5. I got the value of n. Now I need to get the value of m. Now, it is also known that at x equals to 1, both the functions are equal. So 4x plus m should be equals to negative 2x cube plus nx square minus 1 at x equals to 1. So plug in that one. 4 times 1 is 4. 4 plus m equals to negative 2 plus n minus 1. But n is 5, right? So 4 plus m equals to negative 3 plus n. n is 5. So 4 plus m equals to 2. So m equals to negative 2. That's going to be the answer. Find the normal line at the point at the same point. So we have to find the normal line at the same point. So to know the equation of a normal, we need to know the point and the slope. So we know that gradient of the tangent was 4. So gradient of the normal will be negative 1 upon 4. Now I need to know the point. So plug in, what is that? The equation. The equation, in this equation, plug in x equals to 1. So y value will be minus 2 times 1 cube plus n is 5 times 1 square minus 1. So that's going to be nothing but how much? Negative 2 plus 5, negative 1. That's going to be, what is this? 2. So the point is going to be 1 comma 2. So equation will be nothing but what? Y minus y1 equals to m times x minus x1. So you can leave it out over here. Or you can still simplify it further. Find the normal line at the point x equals to 5 upon 3. So now at x equals to 5 upon 3 this time. So what am I going to do it at? I am going to find f prime x. It's not going to be the same slope, right? So it's going to be different slopes. Then find f prime of 5 upon 3. So that will be the slope of the tangent. So minus 6 times 25 upon 9 plus 10 times 5 upon 3, which is going to be 0. So slope of the tangent is 0 means slope of the normal will be 1 upon 0, which is a vertical line. Vertical line will have 1 upon 0. So in that case, x is equal to constant is going to be the, what is this? Equation of the line. So over here the constant is 5 upon 3. So x equals to 5 upon 3 is going to be the answer. That is question number 5. Now coming to question number 6. Consider the function f of x equals to ln x by x cube. Find the first and second derivative of the function and simplify your answer as far as possible. So f prime x. Part A, f prime x. So quotient rule. So denominators square times denominator. Ln x derivative is 1 upon x minus, this time x squared, x cube derivative is 3x square ln x. Then what does that becomes now? X square minus 3x square ln x divided by x power 6. You can cancel one x square, you can cancel it out, x square, and this 6 will become 4. So 1 minus 3 ln x upon x power 4. Then second derivative also have to be found out, f double prime of x. In that case of f double prime of x, so what am I going to do? F double prime x. So again, quotient rule, x power 4 whole square will become x power 8. Then x power 4 times 3 ln x derivative is 3 upon x minus 1 minus 3 ln x as it is. X power 4 derivative is 4x cube. Then what does that becomes now? Negative. This is minus 3 ln x. So negative 3x cube, negative 4x cube plus 12x cube ln x divided by x power 8. So what does that becomes now? Negative 7x cube plus 12x cube ln x divided by x power 8. Now x cube, and x cube gets cancelled. This power 5. So what is that answer? Minus 7 plus 12 ln x upon x power 5. Then the coordinates of the stationary point of the curve and determine their nature. For finding the coordinates of the stationary point, f prime x should be equals to 0. So what was f prime x? 1 minus 3 ln x upon x power 4 should be equals to 0. 1 minus 3 ln x equals to 0. So 3 ln x equals to 1. Ln x equals to 1 upon 3. So x equals to e power 1 upon 3. Substitute x equals to e power 1 upon 3 in the equation. So y equals to ln x upon, what was the equation? Ln x upon x cube. So substitute there to get the y value. Ln e power 1 upon 3 divided by e power 1 upon 3 whole cube. So which is nothing but what? 1 upon 3 upon e. So which is 1 upon 3e. So the point is going to be nothing but how much? E power 1 upon 3 comma 1 upon 3e. That's going to be the stationary point. Now, but we need to know whether it is maximum or minimum. So for that, find the second derivative. Second derivative at e power 1 upon 3, which is minus 7 plus 4 upon e power 5 upon 3, which is minus 3 upon e power 5 upon 3, which is negative. So hence it is, if the second derivative is negative, it is going to be maximum. Then find the coordinates of the point of inflection, justify your answer. To find the points of inflection, what should I be doing it out? Second derivative should be equals to 0. I find the second derivative and equate to 0. So what was the second derivative if you remember? Minus 7 plus 12 ln x upon x cube. X power 5 should be equals to 0. Minus 7 plus 12 ln x equals to 0. So 12 ln x equals to 7. So ln x equals to 7 upon 12. So x equals to e power 7 upon 12. Now the value e power 7 upon 12. So plug in y. Y was ln x upon e cube. So ln e power 7 upon 12 divided by e power, it was x cube, not e cube. X cube, e power 7 upon 12 whole cube. So it becomes 7 upon 12 upon e power 7 upon 4. So what is that? 7 upon 12 e power 7 upon 4. So what is the point of inflection? E power 7 upon 12 comma 7 upon 12 e power 7 upon 4. We need to know whether it is an inflection point or not. So what am I going to do? I am going to draw the table. See, what am I going to draw the table? X and f double prime x. This is e power 7 upon 12, which is nothing but what? 0. Now less than e power 7 upon 12 and more than e power 7 upon 12. So when I take it out, which is, I can take it as e power 0. E power 0, I'm going to get it as negative. Second derivative becomes negative, so it is concave down. Then I'm going to take it as e power 1, which is, I'm going to take it as, it becomes positive, so concave up. So you can see that concavity changes from negative to positive in the second derivative. What was the second derivative? Second derivative was minus 7 plus 12 ln x divided by x power 5. So if I substitute e power 0 in that, if I plug in e power 0, so I get minus 7, then plus ln e power 0, which is ln 1. Ln 1 is 0 by e power 0 whole power 5. So which is going to be a negative answer. So therefore it is concave down. Next time if at all I substitute e power 1, f double prime of e power 1, it becomes minus 7 plus 12 ln e divided by e power 1 whole power 5. We can see that it is a positive answer. Therefore it is concave up. That is the way. Now question number 7. A cubic function ax cube plus bx square plus cx plus d has a maximum point at 0, 5. So, and a point of inflection 1, 1. Find the cubic function. Find the x coordinate of the minimum point. Justify your answer. So, for part A. So, first of all, I'll find f prime x, which is 3ax square plus 2bx plus c. Then I'll find f double prime x, which is 6ax plus 2b. Now he says that it is maximum at 0, 5. So what does that becomes? F of 0 should be equals to 5. So plug in f prime of 0 should, or f of 0 equals to 5, and f prime of 0 also should be equals to 0. Maximum point means there are two options. Substitute that 0 in the question, you'll be getting it at 5. Substitute that 0 in the first derivative, you should be getting 0. So substitute 0 in the question. So what am I doing it at? So 5 equals to a times 0 plus b times 0 plus c times 0 plus d. So d equals to 5. I got d equals to 5. Now in the first derivative also you should be substituting 0 and equal to 0. So substitute 0. So 3 times 0 plus 2 times 0 plus c equals to 0. So c equals to 0. So I got d equals to 5 and c equals to 0. Two answers I got it. Now we know that the point of inflection is 1, 1. So point of inflection at 1, 1. What does it means? There are two options. If I substitute 1 in the question, I should be getting 1. If I substitute 1 in the second derivative, I should be getting it at 0. So I substitute 1 in the question. So a plus b plus c plus d equals to 1. So you know d value, you know c value. So a plus b, c is 0, d is 5 plus 5 equals to 1. So what I get in equation? A plus b equals to negative 4. This is one equation. Now substitute in the second derivative and get it out 0. Second derivative, what do I get it out? 6a plus 2b equals to 0. So this gives me 3a plus b equals to 0. Now you have two equations. Do the simultaneous equations for this both. So 3a plus b equals to 0. A plus b equals to negative 4. Subtract both negative, negative, positive. B gets cancels. 2a equals to 4. So a equals to 2. Plug in a equals to 2 in this one. 6 plus b equals to 0. B equals to negative 6. So what is the equation now? 2x cube minus 6x square plus 5. This is going to be f of x. Now find the x coordinate of the minimum point. So part B, f prime x is nothing but what? 6x square minus 12x. At minimum point, the first derivative should be equals to 0. So 6x common, x minus 2 should be equals to 0. So I get x equals to 0. I will add up a page. X equals to 0 and x equals to 2. Now, what is the thing is, I'll take 2. I'll do the second derivative. Second derivative is nothing but how much? 12x minus 12. Now I find the second derivative at 2. So which is 12 times of 2 minus 12, which is a positive number. Therefore, hence it is maximum, or hence it is minimum. Second derivative is, what is this? Positive means it's going to be minimum. So x coordinate is 2. Question number 8. Find the equation of the normal line to the curve. So first of all, I have to find the dy by dx over there. So this is an implicit derivative. So this kind of derivatives, we are going to use it as implicit derivative. X e power pi, x e power y derivative is e power y dy by dx plus e power y will remain as it is, x derivative 1 minus y square derivative is 2y, y derivative is again dy by dx times e power x minus y square as it is, e power x derivative is e power x equal to 0 derivative is 0. So you can see that this was u v. So this is u v prime v u prime. Again u v u prime. This entire thing is u prime times v then u times v prime. U times v prime. See carefully the derivative. Now the point is 1 comma 1. So plug in 1 comma 1, it becomes, what does it becomes? E dy by dx plus e minus 2e dy by dx minus e equals to 0. So e and e gets cancels. E dy by dx minus 2e dy by dx is minus e dy by dx equals to 0. So dy by dx equals to nothing but what? 0. That's the slope of the tangent. Slope of the tangent equals to 0. So slope of the normal will be equal to 1 upon 0. So it's going to be a vertical line. Vertical line means just now we have learned x equals to constant. So whatever is the value of x. So x equals to 1. That's going to be the equation of the normal line. Part B. Find the equation of the tangent line. Y equals to x power x plus 1. Now when x power x plus 1 is there, what am I going to write it as is, I am going to, you cannot find the derivative directly. So what am I going to write? Y equals to e power x power e power x e power ln x power x. E power ln x power x is x power x plus 1. So which will become nothing but what? Y equals to e power x ln x plus 1. So we cannot use, when there is a variable in the power, we cannot use direct the formula. So we have to convert into a constant in the base, e power ln x power x, so which is e power x ln x. So y equals to e power x ln x. Now I will be finding dy by dx. So what will be dy by dx will become e power x ln x derivative is e power x ln x. Now x ln x derivative, x times ln x derivative 1 upon x. Next time ln x times x derivative 1 plus 1 derivative is 0. So what does that becomes? E power x ln x, then 1 plus ln x. Then that is dy by dx. Now we need to get the slope of the tangent at x equals to 1. So e power 1 plus 1 plus ln 1. So what is going to be that one? The slope of the tangent is going to be e power, it's 1 ln 1 times 1 plus ln 1. Ln 1 is 0 we know. So e power 0, 1 plus 0. So it's going to be 1. The slope of the tangent is 1. Now we need to know the point also. So y equals to x power x plus 1. So y equals to 1 plus 1. So y equals to 2. So the point is 1 comma 2. And he's asking slope of the tangent is 1. So what's going to be the equation? Y minus y1 equals to m times x minus x1. So y equals to x plus 1 is going to be the equation of the tangent. Question number 1. The diagram below shows the graph of f prime x. The tangent line at ABC are parallel to the x-axis. Indicate on the graph above the points the minimum point, maximum point, and what it says, the point of inflection. So which is the point? This is a graph for f prime x. This is not f of x. So this is a graph for f prime x. So f prime x means f double prime x should be 0. So this is a turning point. This is point of inflection because derivative f prime x derivative is f double prime x. So f double prime x should be equals to 0. So this is going to be my point of inflection. So this is also going to be my point of inflection. So that is going to be the point of inflection. Now minimum point and a maximum point. So what is going to be the minimum point and a maximum point? We know that this is going to be your maximum point. Why that's going to be your maximum point and this is going to be your minimum point. Now, because at point of inflection, what happens is the concavity changes. Concavity changes and from where to where? From at point of inflection, concave up to concave down or concave down to concave up. At point of inflection, the concavity changes and also at the minimum points and maximum points, the first derivative is 0. F prime x equals to 0. So f prime x equal to 0 at these 2 points. So I am going to take it as that point. Now coming to over here, that's point of inflection. At point of inflection, over there we can see that this point at over here, the first derivative is 0 and over here also the first derivative is 0. First derivative is 0 at both the points. So therefore one of the point has to be a maximum point and one of the point has to be a minimum point. Now what is happening over there is, and we are sure that over here, let me draw this one. Over here the slope of a tangent is 0. It is parallel to x-axis. So therefore the slope of the tangent will be 0, means the slope of the tangent is f double prime x. So that is equals to 0. Over here also it is slope of the tangent, which is f double prime x, that is equals to 0. So that's why whenever f double prime x equals to 0, that's going to be the point of the inflection. And over here f prime x equals to 0 and over here also f prime x equals to 0. Whenever f prime x equals to 0, then it's going to be the maximum point or the minimum point. So we have found it out what is the maximum point and we have found it out the what is the minimum point of the function. And we also found it out the what is this point of inflection. Now, based on that, we have to sketch the graph of the function y equals to f double prime x by indicating the x-intercepts. Now, how should I be finding it out the graph for f double prime x? Now we came to know that f double prime x is 0 at a. So exactly at a. Over here, it will be 0. And over here also it will be 0. So there will be a point on the x-axis over here because this is a graph for f double prime x. Now we can see that carefully, follow it out carefully over there. What's happening is from this part, for this part, the first derivative is increasing. The first derivative will be increasing. So what is happening over there? From there, from minus infinity till what is the point of inflection, the first derivative is increasing. So therefore, it will be increasing. The first derivative increasing means nothing but what? It is concave down. First derivative is increasing. First derivative is increasing means it is concave down. So it has to be in this way. That is the first one. This is somewhat confusing, so follow it carefully. The first derivative is increasing. Now, for the next part, from here, this point of inflection to point of inflection, there is one maximum point, and what is happening over there is